So today is day 10 for this chapter. We are continuing the chart problems that we started yesterday. So we did 4 examples yesterday. We'll try a few more examples today. Homework will be very similar to the one you had yesterday. Just keeping on practicing. Thank you for the announcement. All right, so an apple sells for 25 cents and a peach sells for 15 cents. A total of 10 pieces of fruit were sold for a total cost of $2.10. How many apples were sold? So what are my 3 columns going to be? Anyone know? So total is this one, right? The number of each is here, and the cost per fruit is going to go there. Good. Oh, they have them flip-flop. That's fine. Okay, cost per apple. Do we know that? 25 cents. Remember, that's 0.25. Cost per peach is 15 cents. Now, do I know the number of either one? No. So that's when I sort of look at where am I going with this? I'm trying to find the number of apples. So if I make apples A, it sort of saves me a little bit of room, a little bit of work at the end of the problem. What do I know about peaches in relationship to that A? There's 10 total pieces of fruit. 10 minus A. Good. Again, if I bought 1 apple, I'd have to buy 9 peaches. 2 apples, 8 peaches. 3 apples, 7 peaches. So you can see that what you're naturally doing when you're figuring this out is subtraction. This, for some reason, this is very hard for a lot of students to visualize. So I always just try to think of real numbers. If you're having that many apples, how many peaches would that lead you to have? And you can kind of see the trend. All right, so the total cost in apples will be 0.25 times A. The total cost of peaches, this is where we have to distribute. And what do I know about these 2 pieces of information? They add to 210. Good, I'm going to stop us here. We talked about yesterday, these kind of have 2 phases. The solving phase you guys are getting pretty good at. The setting up phase is kind of the struggle. So I'm going to stop here. All right, so how should I start this one? Yeah, we can distribute. Or I'm actually just going to put both of these up at the same time. So we did it sort of in reverse yesterday. Here's just showing you that you could do it in either order. You could get rid of the decimals first. So there's a step here that's not really that obvious, but this was all multiplied by 100. Now, the key there is that you multiply only the 0.15. Then you distribute that. You don't distribute the 100, okay? Yesterday we did that, these 2 steps flip-flopped, and it still works, okay? Yesterday we distributed the 0.15 first, and then we got rid of the decimals. I'm just showing you can do it either way. Just don't distribute the 100. Distribute in the next step, okay? So whether you distributed, then got rid of the decimals, or got rid of the decimals, then distributed, you should end up right here. Questions on how we got there? All right, now we can do like terms. So 25A minus 15A is what? 10A. Then subtract 150 from both sides. 10A equals 60. So A equals 6. Good. So that's 6 apples. So what if I would follow up and say how many peaches? What would you have to do? Yeah, you'd have to do the 10 minus 6 and you'd get 4 peaches. That's kind of tricky too on this, is just remembering what they asked you to find. Sometimes students do a little too much work, not enough work, so just make sure you're checking back with the original problem once you get to the end. What are your questions? All right, so this one's reminding me of the homework question last night, right? The carrot celery, so we're talking about calories. A cup of skim milk has 10 more calories than a glass of apple juice. If the total number of calories in 1 cup of each is 370, find the number of calories in each. So, very similar setup here. We're talking about milk and apple juice. So one column is going to be what? Calories will be 1. I'm not sure which one is going to pop on, but it doesn't really matter. What's the other one going to be? Yeah, how much of it do you have? So calories, how much, or maybe how much, then calories. I'm not sure how it's programmed. But those are going to be multiplied together to give you the total calories of each, okay? So let's start setting it up. All right, what do I know about the calories? There's 10 more calories in a glass of apple juice. So whatever variable I use here, I'm going to use that same variable plus 10 down here, okay? Now, what's the amount of each? 1 cup. So I'm going to have that set up. So skim milk has 10 more calories. So if we're using an A for apple juice, we do an A plus 10 for skim milk. Was I pointing to the wrong boxes a minute ago? Yep. I'm sorry, I wasn't looking at the labels. But yeah, so just whichever one has more, that's where the plus 10 goes. Skim milk does have more, my bad. Now, this is actually really nice that they only have 1 cup, because you don't really need to distribute a 1. You know what I'm saying? Make sense? Yeah, so there is a step where we're multiplying the 2 columns, but it doesn't do anything. So the equation that we solve is actually going to be a fairly easy one. It's just A plus 10 plus A equals that total number of calories from a cup of each. This is where we shift from the setting up to the solving. Questions? All right, it's just a combine like term. So 2A minus 10 minus 10. Divide by 2, divide by 2. Okay, so what does this represent? Now we actually have to make sure that and I did that pretty fast. I'm assuming you guys can do this by now, right?
But don't you gotta add 10 for skim?
Yes, so this represents the number of calories in 1 cup of apple juice. That's where I put my variable. But the question asked me to find the number of calories in both. So to find the skim milk, you simply add 10. So 180 calories for apple juice, 190 for skim milk. Okay, in a game played with white, blue, and red chips, one player had twice as many blue chips as white chips and 3 more red ones than blue ones. White chips are worth 1 point, blue chips are worth 2 points, and red chips are worth 3 points. How many of each are there if the player has 165 points? What? You know what I mean. Just read it. Okay, so we're talking about 3 things. So now my chart has 3 rows. All right. Now, this is similar to the ones with the quarters, nickels, dimes. You know those? Except now instead of money, it's points. So we're going to talk about how many chips we have in one column. What's the value of each, and then the total. Okay? So number of chips, value, total. In a game, yes, this sounds like a poker game. One player had twice as many blue chips as white chips, and 3 more red chips than blue chips. So I think it will be easiest if we start with the white. So I'm going to call the white W. What do I know about the blue? Twice as many. What does twice as many mean? Times 2. So this is going to be 2W. Here's where it gets really fun. 3 more red ones than blue ones. So 2W plus 3. Yes, you can still take it back in terms of W. We just use this instead of blue. Because the 5W would be 5 times as many as the white. They're not like terms. I know. All right, how much is a white chip worth? 1 point. 2 points. 5 points. All right, so the total for white would be what? 1W. The total for blue would be what? 2W times 2, which will end up being 4W. I heard someone say 4W. That's absolutely correct. The total for red would be 5 times 3 plus 2W. Honestly, I would just do 2W plus 3. I don't know. It just makes more sense to me. But remember, addition is commutative, so that doesn't really matter. And when I add all 3 of these, 165. All right, I'm going to pause here so you can catch up. Was that as hard as you thought it was going to be? Yes. No. All right, let's go through and multiply. So the W is just fine. What's 2 times 2W? We already talked about it. 4W. Distribute the 5, so we have 15 plus 10W. Still equals 165. We got lots of like terms. How many W's do you end up with? 15W plus 15. 15.
Why you say 15?
You said 16.
It's all good. Good. Okay. I know. You guys are so mean when someone makes a little mistake. All right. Now what? Subtract the 15. Divide. So W equals 10. Now, did they ask us about the white chips or all the chips? All the chips. So white chips is 10. What's blue chips? 20. What's red chips? 23. You basically just plug it back into that column with all the W's. Okay? W stood for the number of white chips. We had twice as many blue chips, so 2W, 2 times 10, 20. 2W plus 3 was red chips. Plug the 10 in, you get 23. What are your questions? Nothing? All right, here is number D. Oh, we love these.
Do we?
Yes, this is the final example of the day. And then you'll have like 15 minutes to do homework, and it's Friday, and you're all complaining about Friday homework, so you're going to just get it done. I know. I know. Okay. When you're ready. Y'all ready? Y'all ready for this? All right, a stalk of celery contains 7 calories, and a carrot contains 20 calories. A total of 45 carrots and celery stalks contains a total of 575 calories. How many carrots are there? So, similar idea here, except we know the information we didn't know in last night's homework. Now we know how many calories are in each. So, I'm trying to find how many there are. So calories are locked in. 7 for celery, 20 for carrots. I'm trying to find the number of carrots. So that's where I'm going to put my variable. Hardest box is the one that's left. Any ideas?
I thought we knew. No, it's a total of 45 carrots.
45 is the total of both.
Oh, I thought it was just
C minus 45 would be if there were 45 less celeries than carrots. Somebody said it. 45. What are you saying? 45 minus C. I thought you just said 45. I was like, no, 45 is the total. 45 minus C. Again, if total they have to add to 45. We don't know how many there are of each. But I do know that no matter how many there are here, I need to take that away from 45 here. Again, if there were 5 pieces of carrots, or just carrots, how do you say it? 5 carrots, there would be 40 celery stalks. If there were 10 carrots, there'd be 35 celery stalks. What you're doing naturally in your head there is taking 45 minus the number of carrots, okay? Tricky, you're going to get it. I'm confident you will figure that one out. Now, total for celery would be what? 7 times, in parentheses, 45 minus C. Total for carrots is what? 20C. Then what? Put it in the equation. What do you mean? Plus, yeah, you got to add those two expressions and it equals what? 575. Good. Okay, questions on the setup? All right, here's the part where you guys are doing really, really well. What do I do first? Distribute the 7. 7 times 45, I'll do the hard part for you. It's 315. 7 times minus C is minus 7C. Plus 20C equals 575. Now what? Yes?
Me?
Yeah.
Me? Whatever you do with the like terms.
The like terms. Now this is a place where I know it would be tricky. This is a negative 7. This is a positive 20. You subtract them, keep the sign of the larger one. Sure, now what? Subtract the 315 from both sides. Divide by 13. 20. Now, does it ask us for both or just carrots? Just carrots, so I'm done. 20 carrots. All right, today we learned, we can do this pretty easily because we also learned this yesterday. So I'm just going to put today we learned more charts. So our summary was a little longer yesterday, but pretty much the same thing. All right, here comes your homework. You will be quiet and do it because I don't want you to forget about it over the weekend. Just get it done.